How is magnification used in metallography? Imagine trying to read a tiny, intricate puzzle with your eyes alone. Without help, many details stay hidden. That's where magnification comes into play in metallography. It's a key tool for examining the tiny world inside metals and alloys. When metals are made, they have a microstructure that affects how they behave and fail. To see these microscopic features, scientists use microscopes that enlarge the image of the sample. In metallography, the process starts with preparing a sample. The sample is embedded in a resin, polished smooth, and then etched with chemicals. This reveals the internal structure, like grain boundaries, phases, and inclusions. Once prepared, the sample is placed under a microscope. The most common microscopes used are optical microscopes, which can magnify images from about 10 times to 1,000 times. This range allows us to see the size of grains, the shape of phases, and the presence of tiny defects. Magnification helps identify if the metal was processed correctly. For example, if the grain size is too large or too small, it can weaken the material. By examining at different magnifications, analysts can get a full picture of the microstructure. Sometimes they need to go higher, up to 2,000 times magnification, to see finer details like microcracks or small inclusions. But beyond a certain point, increasing magnification doesn't show anything new. It just makes the image bigger, which is called empty magnification. Different imaging modes add more detail. Bright field illumination shows a clear view of polished surfaces. Dark field makes surface defects like scratches or pits stand out by capturing scattered light. Polarized light and differential interference contrast techniques reveal stress patterns and crystal orientations that are invisible under normal light. These methods help pinpoint issues that could lead to failure. For even more detailed analysis, electron microscopes like scanning electron microscopes are used. They offer much higher magnifications and can tell us what elements are present in tiny areas. But usually, optical microscopes are the first step. They help determine if advanced techniques are needed. In failure analysis, magnification is essential. It allows investigators to spot cracks, inclusions, or phase changes that might have caused the metal to break down. By carefully examining these features, they can trace back to manufacturing flaws, material degradation, or operational stresses. To sum up, magnification in metallography is a vital tool. It helps us see the microstructure at different scales, revealing the features that influence a metal's strength, durability, and failure. This detailed view is what guides engineers and scientists in diagnosing problems and improving materials.